Now, next topic is continuous charge distributions. This one we have discussed at the same time. We have discussed continuous mass distributions in the previous 11th topics. There are also linear mass density, surface mass density, and volume mass density. Linear mass density means mass per unit length. Surface mass density means mass per unit area, and volume mass density means mass per unit volume. Similarly, here also charge is distributed over a surface. That means charge can be distributed along its length, charge can be distributed along its area, charge can be distributed along its volume. So why it is necessary? As of now, whatever we have discussed, these are all we have discussed about point size charges. That means discrete charges also we can calculate. That means we are calculating electric field due to a single point charge, and also we are calculating due to the multiple charges, means simply we are adding. That adding, in case of continuous distributions, instead of adding vector addition like single charge, we will use a integration. Instead of that, summation is replaced with integration, and we will do it. Before it, we need to define what are the different types of charge distributions are there, continuous charge distributions. The first one is, we can say here, linear charge density. Linear charge density, which was denoted with a lambda. That means, suppose if you take a rod and the charge is uniformly distributed linearly with a linear charge density lambda, then I would like to find the charge over a small length of the length dx. That means I can say dq. Here lambda is called linear charge density. The definition of linear charge density is charge per unit length. Note on the definition. Linear charge density is called as charge per unit length. Charge per unit length. Due to that reason, lambda can be written as charge per unit length. Now, I would like to find the charge over a length of dx. Therefore, I can write lambda equal to dq by dx. Suppose this surface is having a total charge of capital Q and its length is L. Then what is the charge over this? That means here we can do in problems while doing dq by dl is equal to lambda, which we can write as total charge by total length. Therefore, charge over of that length can be written as q by L into dx. And we will integrate and we will simplify the numericals. Now, next definition is surface charge density. Surface charge density. Generally, it is denoted with a letter sigma. Surface charge density means, just like our previous definition, charge per unit area. Charge per unit area. Let's assume a disk. And over it, a charge is distributed uniformly with a surface charge density sigma. Then I would like to find the elemental area. That means let's assume a shaded portion of yellow color, whatever I'm shading, whose thickness is dx, whose thickness of this region is dx, and its radius is x. I would like to find it. Then this elemental area also you can say as dA, and what is the charge over this elemental area means dq. Then I can write, by the definition of surface charge density, I can write it as sigma equal to dq by dA, dq by dA. Now, if you would like to find what is the charge over this wind means, just like simply whatever we have done like that only will follow here. Sigma equal to dq by dA, and here total charge of capital Q is distributed over its radius of r. That's why I can write q by pi r square. Then I can write dq as q by pi r square into dA. And here dA is equal to 2 pi x perimeter into thickness, and we can integrate, we'll get. Similarly, the third definition is volume charge density. volume charge density, which we can call as rho. That means you can define here charge per unit volume, charge per unit volume. Then I can say it is denoted rho, that's why dq by dv. Then if you consider a sphere whose volume is V and charge is distributed uniformly over it. Now we'll consider any sphere of radius x and thickness is dx, and we'll calculate. That means the charge over it is dq and the volume is dv. We can find this one as dq by dv rho equal to, that we can write as total charge over the surface is, let it be capital Q, and volume is 4 by 3 pi r cube. Then we can calculate dq as 3q by 4 pi r cube into dv of the surface. Here in this situation, the value of dv is 4 pi x square into dx, surface area into thickness of that sphere. This is about 3 types of charge distributions, and we will do in numericals this type of charge distributions, and in derivations also we will. Please try to remember the definitions and learn it fast.